All right, here we go. Um, what are we doing right now? We're doing 4.2. All right, so we talked about this in class. Um, and I realized about 5 minutes ago that I forgot to mention something. All right, I totally skipped number four. It's kind of sneak it in here. All right, so they want to know what is the antiderivative. All right, what is the antiderivative of 12x over 1 minus 36x to the fourth? So an antiderivative, it's like it's the answer to what we would get um, if we took a derivative. So like for example, x squared, the derivative of that is 2x, right? The antiderivative is just working backwards. Sometimes we call this like the integral. So the antiderivative here is, what it would require to get the derivative as an answer, right? So if we look at this thing, we have 12x over the square root of 1 minus 36x squared. So if we look at just the structure of this function here, we have a square root on the bottom, and we're going to have 1 minus something squared, right? So let's look at our inverse trig derivatives here. So if we just look at which one of these is that most similar to, it looks like the sine function. All right. Now we have this 36x to the fourth. Well, we have to think, if I square something, what's going to give me 36x to the fourth? That is going to be well, what is that? Well, let's square root 36x to the fourth. What is that going to give us? That gives us 6x squared. All right, so I'm going to put a 6x squared right there. All right. And how do we get that thing on the top? Well, we just, according to the chain rule, we have to take the derivative of the outside times the derivative of the inside. So if you look at 6x squared, if you take the derivative of 6x squared, you get that 12x there. All right. So, I'm gonna go ahead and put that 12x right here. All right. And let's just look at the inside here. This 6x squared kind of corresponds with the x on the inside right here. So the antiderivative to this answer is going to be the inverse sine of 6x squared. All right. Now, if you wanted to confirm that, just go ahead and take the derivative of this guy. The inverse sine of 6x squared does, in fact, give you the answer of 12x over 1 minus 36x to the fourth. All right, so we're really kind of thinking backwards on these things. So maybe let's go in the notes and find one of these here, or I guess on the homework. All right, number 9. Find the antiderivative of this thing. All right, so I see a 25x squared on the bottom. So if we just look at the inside, it's 1 minus something had to get squared here. All right, well, how do we get that? Well, if you look, square root of 25x squared is 5x. Right? Well, if you look at the derivative of 5x, the derivative of 5x is 5. All right, so this one right here, we already can tell this ends up being the inverse sine of 5x. Right? Because if we compare the derivative of the inverse sine, it looks like that same exact structure. All right. Here, let's try this next one. All right. So first things first, I see the negative. All right. So I told you guys any of the negative ones are the co-derivatives. So cosecant, cosine, cotangent. All right. This one does not have the square root in it, so I can already tell you that this one is going to be the inverse cotangent. All right. Now, what is going to be on the inside? I don't know. Let's just kind of think about that. If we kind of work backwards here, we know it ends up being 1 plus, and then we had something squared. All right, so let's look at 4x to the sixth. What is the square root of 4x to the sixth? Well, that's just 2x cubed. All right, so there's going to be that 2 x cubed. All right, what is the derivative of 2x cubed? Well, that's 6x squared. All right, so there we have it. That is our answer. So this ends up being 2x cubed. That is the antiderivative of this function here. All right, so try some of those. I think there's a couple on the next page here. So number 19, that's an antiderivative, 24. So see if you can do some of those on your own. All right, now I do want to revisit this thing. I feel like I didn't do you guys justice on this, so I'm going to try to do this again. All right, we said the derivative here, d dx of f inverse, that is going to be 1 over the derivative of f prime of f inverse of x. All right, if we say f inverse of x, right, sometimes it's easier to, instead of having this -1 notation, it does get clunky sometimes. If I say this is equal to g of x instead, right, then I could say, okay, this is just going to be equal to 1 over f inverse of g, I'm sorry, f prime of g inverse of x. All right. So this would be equal to, if I were to substitute everything out, this would be equal to g prime of x. Right. So let's try that again. All right, let's look at one of these things. F of 12 is equal to 4. So we know f of 12 equals 4. All right, this implies that 12 equals g of 4. All right, so we already know what g of 4 is because we said f and g are going to be inverses of one another. So instead of saying f inverse of x, I'm just going to call it g. All right, so if we were trying to find g prime of 4, all right, this is going to be equal to 1 over f prime of g of 4. All right, now we know what g of 4 is. We said g of 4 is 12. So this ends up turning into 1 over f prime of 12. Right. But we know what f prime of 12 is. Right. F prime of 12 is just -5. So this turns into 1 over -5. Or if you want to throw the negative on top, you call it -1/5. Right, or throw it on the outside, that's fine too. Right. And that's really all there is to these things. So just for the sake of completion, doing the next one, f of 3 equals -2. All right, what does that mean? Well, that means 3 equals g of -2. Because again, the whole reason we can say all of this is right here. All right, that sentence right there tells us f and g are inverses of one another. All right, so g of -2 already done. So let's find g prime of -2. G prime of -2 is equal to 1 over f prime of g of -2. Let's not miss our negative sign in there. All right, and then plug that in. That's going to be equal to 1 over, we have f prime. Let's see here, g of -2, we said is 3. Well, f prime of 3 is 5. Positive 5. All right, and again, I know that from right here. All right, so that one's done. So there's several more like these. But so I went when they tell you just straight up like, 2 of the answers. But sometimes it's not always the case because sometimes we have functions, right? So if I look at this one, f of x equals 2x cubed plus 4. All right, we're looking for the derivative of f inverse. All right, so again, instead of saying f inverse, maybe you could call it g if you wanted to. All right, so we can algebraically find uh, this inverse relatively easily, right? So we always said, like, if we're thinking back to algebra 2, we have y equals 2x cubed plus 4. All right, and then kind of the first step, switch the x's and the y's. So we're going to say x equals to 2y cubed plus 4. And then we're going to solve for 4. So we got x minus 4. I'm going to subtract the 4's over first, then divide away the 2's. That equals y cubed. All right, well, I just want y by itself, so I'm just going to go ahead and cube root both sides. I'm going to say this is the cube root of y. All right, so instead of saying this is y, I'm going to just rename it. So this was kind of our last step. So we said f inverse of x equals, with the cube root of x minus 4 all over 2. All right, so now we have we have the inverse. We can figure out, hey, what is the derivative of that? So we could definitely take the derivative of this guy. It's very doable, but I don't really want to do that. I mean, I guess we could. No, I haven't done that. All right, I'm just winging it now. The cube root, I'm gonna go ahead and say, let's see, d dx of f inverse of x. Let's see, that's going to be x minus 4 over 2. That's all to the 1/3 power. Actually, these are not equal. So let me get rid of this d dx. All right, that's what it is. So now if I take the derivative, so now we're going to say d dx of f prime of x, f inverse of x. Power rule says bring the 1/3 down front. And then we're going to have the x minus 4 all over 2. And then we're going to have a negative, what is that going to be? Negative 2/3 here. And then times the derivative of the inside. The derivative of x over 2 is just going to be 1/2. All right. So that's the derivative. So I think, what do they want us to plug in? They want us to plug in a 20. All right. So if I do that, if I say the derivative of the inverse of that 20, all right, I don't have a clue what this is. 1/3 times 20 minus 4 over 2 to the negative 2/3 times 1/2. All right, let's see here. 20 minus 4 is 16. 16 divided by 2 is 8. That's going to be 2, 4 on bottom. So this equals 1/3 times 1/4 times 1/2, which gives us 1 over 24. All right, so that's how we could do that if we were to actually just kind of brute force finding the derivative 1/24. Now, let's do it using the formula that we derived, that we worked so hard for, that's on one of these pages. All right, we're going to use this formula instead. I think it becomes a little bit easier. All right, so let's see here. According to the previous page, we know d dx of f inverse of x is equal to 1 over f prime of the inverse of x. All right. Well, is that easier? I don't know. What do I have in my notes? I don't have my notes with me. So let's see here. This ends up being, well, we don't know the derivative. Let's figure out the derivative. f prime of x equals 6x squared. All right, so this equals 1 over 6 times, let's see here, I have to plug in the inverse on this thing. That is the cube root of x minus 4 all over 2. And then I think I have to square this thing, yeah. And then, of course, I'm plugging in a 20, so I'm just going to say x equals 20. So that gives us 1 over 6 times the cube root of 20 minus 4 all over 2. And then squaring that. I think we're onto something here. So let's see here. 20 minus 4, 16, that's 8. Cube root of 8 is 2. 2 squared is 4. And then 4 times 6 is 24. So that gives us 1/24, which I think is what we got last time. So let's see. Yeah, all right. So there you go. There are 2 ways to do that. So we can find the inverse, take the derivative and plug it in. Or we can use this kind of formula that we've established. Now, is one easier than the other? In this case, not necessarily. I kind of like the first way more. However, it doesn't always work because if we look at this guy, f of x equals x cubed plus x plus 1. And they're saying find the inverse of 1. We would do step 1 by taking the derivative, trying to find the inverse. So you're going to swap your x's and your y's, and then you're going to solve for y in this case. The only issue with this, you cannot solve this algebraically for y, right? There is no algebraic solution to this, or if there is one, I don't really know how to find one very easily. So we're going to have to kind of think about this in a little bit of a different way here. All right, so if I just look at this first one, all right, let's just think about what inverses mean. All right, so if I want f of x, all right, f of x equals, something, it's going to give me an input, all right, but the inverse kind of gives me the output, and I have to figure out what is the input. So what I need to do on this thing is I need to say, all right, I'm going to set f of x equal to 1. All right, then I'm going to solve. I'm going to solve for x here. So if I do that, let's just say 1 equals x cubed plus x plus 1. All right, I need to figure out, hey, what value of x is going to make the answer equal to 1? That's kind of what the inverse does. Now, I can't find an algebraic expression for that, but I might be able to solve for that value of x here, right? So if I'm going to make that y value, or the f of x, equal to 1, right, let's just see what happens. So I can subtract 1 over, and we're going to have 0 equals x cubed plus x, right? So that just goes away. Now, look at this. We can factor this. I'm going to say, hey, 0 equals x times, we're going to have x squared plus 1. And that is something that we can solve. So we know x equals 0, and then 0 equals x squared plus 1. Now, if I look at the second one here, right, you'd subtract the 1 over, you're going to get negative 1 equals x squared, square root both sides, and you're going to get x equals plus or minus I, the imaginary number. It's probably been a while since we've talked about that one. So that is kind of an issue here, right? So we don't want the imaginary numbers in here. We're kind of looking for, those real number solutions. So we're going to take this x equals 0 here. All right. So keep in mind, what are we trying to do? We are trying to figure out what is the value of f inverse prime of 1. All right. So we want to figure out dx of f inverse of 1. Now, according to that formula, we know this is just equal to 1 over f prime of f inverse of 1. All right. Well, hey, we know what this guy is. F inverse of 1. We found one of the answers, right? One of the real answers was 0, right? So we're going to have to kind of restrict the domain on here because we're not going to get into imaginary numbers right now. So the derivative of f inverse of 1 is equal to 1 over f prime of 0. All right. Well, what is f prime of 0? Well, we can figure that one out really quickly. Let's go ahead and just take the derivative. F prime of x is going to be equal to 3x squared plus 1. And all we have to do is plug in a 0 for that. So f prime of 0 just equals 1. So this is equal to 1 over 1, which is 1. Right? So our final answer here is we know f inverse prime, or I don't like that prime, I'm going to say ddx. I think this notation is a little bit more friendly in this case, right? Of 1. Actually, here, I got my brackets in the wrong spot. Of 1 is equal to 1, right? So we can calculate these derivatives of these inverses without necessarily finding the equation for the inverse of this function. And that's kind of useful, right? If you look at the one up top, we found it very easily, right? So we could brute force it. But if we kind of use this theorem or this formula that we've derived on a previous page, it does make life a little bit easier, right? So this is pretty much just more of the same. We could do it again on this one. I don't really want to do it again. Right, and here's the same one as well. But let's see. Can we do this one? Yeah, we can do this one. All right, so we are going to have we're looking for f inverse the derivative, so ddx of, so they're saying do it when a is 1/2. All right, so we need to set this guy equal to 1/2. All right, so let's just say, all right, 1/2 equals the cosine of x. All right, where is cosine of x equal to 1/2? As long as our domain is between 0 and pi, right? So go ahead and draw up your unit circle. If you don't have these things memorized, go ahead and draw your angles out. We got a 1. Let's see here. We have cosine would need to be 1/2, and this is a square root of 3 over 2. All right, so what angle is this one? I believe that is a, let's see here, this should be a 60-degree angle, but AP only ever uses radians, so let's go ahead and call this pi over 3. All right, so we know x must be equal to pi over 3. And that is useful. All right, so let's go ahead and try to calculate this thing. So the derivative of f inverse of 1/2 is equal to 1 over f prime of the, let's see, why am I drawing a blank? Inverse of 1/2. So, well, what is the inverse of this one? Well, that ended up being pi over 3. So this is going to be equal to 1 over f prime of pi over 3. But we need to figure out what f prime of pi over 3 is. So if f of x, remember f of x was equal to the cosine of x, what is the derivative of the cosine? All right, so f prime of x here, that's negative sine of x. So this is going to be equal to 1 over negative sine of pi over 3, which is equal to 1 over negative square root of 3 over 2, which is equal to negative 2 over square root of 3. If we wanted to rationalize that one, we could call this negative 2 square root of 3 over 3. And that is our answer. All right. So there we have it. Another one of these inverse derivatives, right? These things get a little bit tricky. But once you kind of put it all together, I think they're kind of fun little puzzles here. All right, so I'm on a roll. I'm just going to keep going. Suppose t is the inverse of r and r of 17 equals 6. All right, so what this means is t of r of x equals x, right? Because they're inverses of one another. So this means if we take the derivative of both sides, we get t prime of r of x times r prime of x equals 1. Therefore, r prime of x equals 1 over t prime of r of x. All right. Let's see here. What do we need? We need to find t and t prime of x. All right, so I did the opposite one. So that's okay. We can figure this out because they are inverses, so it's going to look exactly the same deriving the other formula. Take the derivative, r prime of t of x times t prime of x equals 1. Divide both sides. You got t prime of x equals 1 over r prime of t of x. All right. So find t of 6. That's easy. T of 6 is a gimme because we know r of 17 equals 6 because they are inverses. This implies that 17 equals t of 6, r of 6. No, t of 6. Right the first time. So t of 6 equals 17. All right. So we need to find t prime of 6. So t prime of 6 equals 1 over r prime of t of 6, which is what we already found, right? So this is 1 over r prime of, well, t of 6, right? We know t of 6 is 17, right? And I'm guessing they tell us what r prime of 17 is. R prime of 17 is 2/3. So this is 1 over 2/3, which is equal to 3 halves. All right, so t prime of 6 is 3 halves here. All right. Let's just do one more. Oh, I don't know. How about let's do number 1. All right, number 1. Let g of x be x to the 5th plus 3x minus 2. Let g inverse denote the inverse, or g negative 1 inverse. All right. We are looking for g inverse prime of 2. All right. So here's what we're going to do. All right. Kind of first things first. Set g of x equal to 2. So I'm going to say 2 2 equals x to the fifth plus 3x minus 2. All right, now, same kind of process. We need to figure out what is the value of x going to be. We need to solve this for x. So I'm going to say 0 equals x to the fifth plus 3x minus 4. All right. From here, we could do, and we could absolutely do this, we could do synthetic division. All right. Which will work, right? But unfortunately, we need to figure out what value of x is going to give us that 0, that first 0. We just kind of have to do that P over Q thing. That's too much time. I don't really want to do that. So here's what we're going to do. We're going to go to Desmos, and we're just going to type this equation in. We're going to say y equals, it was x to the fifth plus, I think it was x cubed, and then minus 4, maybe? What was that equation? Don't want to mess it up. Oh, it's 3x, sorry. All right, so here we go. This is our function. Notice how it kind of, it's a quintic function, but it looks like it only crosses once. So that means we're going to have some imaginary solutions here. But one of those answers is x equals 1. All right, so I'm going to go ahead and plug that one in. We know x equals 1. All right, and we got this from the graphing calculator. You know what? Maybe it's a good idea if I show you how to do that graphing calculator. So let's load this up. Right on here, type in the function that you need. So this one is x to the fifth. If you know how to do this already, sorry, maybe skip forward in the video, but it's just a good reminder. All right, x to the fifth plus 3x minus 4. All right. Make sure your window is all set. All right. I usually go, this is a standard one, -10 to 10 and all that good stuff. All right. And it's going to graph it. Now, it looks like it's right at 1. However, if we want to confirm that, you can press second, press the blue button, and then calculate, and then go to number 2. That's your 0. Right? It's going to say left bound, so you need to kind of go to a little bit to the left of where that 0 is, press enter, and then go a little bit to the right of where it is, maybe right there, press enter again, and then it's going to find the 0 anywhere between that interval, which in this case is at 1. Right. Now, this does factor into something. I don't know what it is. I don't really care what it is because I'm just after that solution, that 0 there. All right. So we know x equals 1. This is the solution to g to the negative first power of 2. All right. That equals 1. We're going to use that because we know the derivative of g inverse of 2. We know this is equal to 1 over the derivative of g. And then we have on the inside the inverse of 2. Right? Just like that. Well, let's just go ahead and plug it in. This is equal to 1 over g prime of 1. But we need to figure out what g prime of x is. We just had a test over that, so hopefully that is fresh in our minds. What is the derivative of this guy? That's just going to be a quick power rule. You can say 5x to the 4th plus 3. All right, so if we plug in a 1 for that, g prime of 1, maybe I'll do that down here. G prime of 1 equals 5. That's 1 to the 4th plus 3. All right, that's going to give us 5 plus 3, which is 8. All right, so this turns into 1 over 8. All right, so which is letter B. And there we have it. That is the derivative of the inverse evaluated at 2. Right, so there we have it. So there are a few more. This next one here, number 2, that is 1/4. All right, so that's what I got. The answer for number 2. For number 3, I got, what did I get? On number 3, I got 1/6, positive 1/6. All right, so see if you guys can get those same answers as well. All right, that is 4.2. I'm gonna make another video. Sorry about that. But that was really long. Sorry. But good luck.